In this lesson, we're going to look at how to graph a quadratic function. So the parent function of quadratics is in the form of f of x equals x squared. Okay, that's our most basic quadratic. So to get a sense of what the graph looks like, I always select some values. So for x, I'm going to choose 0. When I find 0 squared, that's 0. Plug in 1. 1 squared is 1. 2 squared is 4. But I also like to plug in some negative values. Negative 1 squared is also 1. Negative 2 squared is 4. I could continue. 3 squared is 9. Negative 3 squared is positive 9. And let's sketch what this looks like. If I would connect these points with a smooth curve, it doesn't come to a sharp point there at the vertex, this is known as a parabola. Every other quadratic equation is going to take on this shape, but it will differ depending on the values included. The domain of this parabola is negative infinity to positive infinity. All quadratics have that domain. It goes infinitely left, infinitely right. Now the range is a little different. The lowest this parabola goes is here at 0, and it goes infinitely upward. Since 0 is included on the graph, it gets a bracket. Reminder of some vocabulary. So the point where the parabola changes direction is your vertex. Where it crosses the y-axis is your y-intercept. Where it crosses the x-axis, that's your x-intercept, also known as your zeros of the function or solutions. Parabolas are symmetrical. The vertical line that would go right through the vertex is known as your axis of symmetry. Since it's a vertical line, it's always going to be in the form of x equals some value. There are 3 forms that a quadratic equation could be given to you in: standard, vertex, or intercept form. Let's start by going over standard form, and then quickly we'll brush through the other 2. So standard form, y equals ax squared plus bx plus c, where a, b, and c are just real numbers. So the vertex would be a point, and that point is found by doing negative b over 2a. If you remember, that comes kind of from the quadratic formula. And once you have that x value, you're just going to plug that back into your function. So I'm going to write that as f of negative b over 2a. Okay, so you find x, plug in to get y. Your axis of symmetry, again, is your vertical line through the vertex. So that's going to be in the form of x equals, well, whatever that x value is that you just found, x equals negative b over 2a. If you completed your discovery in Schoology, you should have seen how a controls the shape of the parabola. If a is greater than 0 or it's positive, your parabola opens upward. If a is less than 0 or negative, your parabola is going to open downward. When you look at the numeric portion of a, or the absolute value of a, if it's a value smaller than 1, your parabola ends up being wider than the parent function. So wider than y equals x squared. Whereas if it's greater than 1, it's almost a little counterintuitive, it ends up being narrower. And we'll talk about this in terms of stretches and shrinks. If it's exactly the same as 1, well, then it's the same as your parent function. Okay, so let's talk our other 2 forms, vertex form versus intercept form. So vertex form, no shocker, gives you the vertex. And the vertex is your h and your k value. So h and k are just numbers. So h comma k is your vertex. So there's less work when it's given, the parabola is given in vertex form. Now, I always say opposite, same, okay? So it's the opposite of the number you see inside parentheses, and then the same as the number that's being added or subtracted at the end. The axis of symmetry is, well, it goes through your vertex, so it's x equals h again. Now, the nice thing is here, you don't have to learn any new values for how a affects the graph because the a value is the same as when it's in standard form. Intercept form, this is when your function is already factored. So intercept form gives you your 2 intercepts. So it's this value, and again, it's always opposite of what you see, is going to be where it crosses the x-axis. So p0, and then this value q0 is your other one. The vertex. This one, I just like to think it through. I'm not good at memorizing. So if I have a parabola that cuts through the x-axis, because it's symmetrical, the point where the vertex is going to be halfway between those two intercepts. So how do I get halfway between? Well, if I add the two intercepts together and then chop it in half, divide by 2, that's going to give me the x-coordinate of the vertex. And then how do I get the y? Well, I always just plug it back in. So I'm going to write that as f of p plus q over 2. Kind of crazy math notation, but it's just telling you plug it back in to find y. So your axis of symmetry, well, again, is always a vertical line. X equals, well, the p plus q over 2. Okay, so these are the 3 forms that we're going to put into practice. Okay, let's do these quick 3 examples. First of all, we're supposed to find the direction that the parabola opens. So I'm going to look at A. Because A is -2, this one opens down. This one opens up because it's positive. This one's positive, so it opens up. And then let's talk about part B. Is it wider or narrower than the parent function? So since the absolute value of A is bigger than 1, this one is narrower. The second one is smaller than 1, so it's wider. It compresses your graph. The next one is smaller than 1, so it's also wider. Okay, we're supposed to find the axis of symmetry and our vertex. So I think I'm going to go and do the vertex next. So for standard form, I need to do -b over 2a. So that would be 0 over 2 times -2. So it's going to equal 0. And then I need to plug that into the original function, and I get -5. So there's my vertex. So my axis of symmetry is always x equals the x-coordinate of the vertex. The second one is in vertex form. It's easier. Go opposite, same. Opposite of 8, the same as 13. So -8, 13. And my axis of symmetry would be x equals -8. The next one is a little trickier because it gives us where it crosses the x-axis. So it's going to cross at +3, 0, and +3, 0. So what does that mean? Well, if I add 3 and 3 together and chop it in half, I'm going to get 3 again. So in other words, the x-intercept is the same as the vertex here, so it's crossing at 3. If I plug 3 in, I already know I'm going to get 0. So the axis of symmetry is always x equals the x-coordinate of the vertex. You can try 4 on your own. And let's do a sketch of our graph for 5. So again, standard form, so I'm going to start by finding my vertex. I do -b over 2 times a would be +2 over 2 times 1 is going to equal 1. If I plug 1 into my function, I would get 1 squared minus 2 is -1, plus 1 is 0. So 1, 0 is my vertex. So I'm going to plot that. My axis of symmetry is a vertical line straight through here. So line x equals +1. And I know this parabola is going to open upward because a is positive and it's going to have the same width as my parent function. Some other points on this parabola. I am going to plot my vertex in the middle and I pick a few values to the right. I'll pick 2 and 3 and I'm going to plug those into the function. When I do, I get 1 and 4. Now the beautiful thing here is I know it's symmetrical. So if I go 0 and -1, 2 points to the left, I know these values here have to be the same. So this has to be 1 and this has to be 4. And let me show you over in the graph. So when I plot these at 2, 1 right here and 3, 4 here, I know that this is 1 unit away. So there has to be a point 1 unit away, which is the point 0, 1 that we found. And this point is 2 units away, so there has to be 1 2 units away right here. So my parabola is going to be like this, goes infinitely upward. Let's talk domain. So the domain of all parabolas is -infinity to +infinity. It goes forever left and forever right. The range Well, the lowest value here, the height of it is 0, and it goes infinitely upward. So 0 is included on the graph, it gets a bracket, and the range goes infinitely up. Thanks for watching. As always, reach out if you have questions.